Hello everyone, this is KP the Math G here. I've got that name from students when I was teaching calculus, AP calculus several years ago, and the name has stuck, so we're going to stick with the name. The question today to you is, what is a derivative? A derivative is a rate of change. Any rate of change, kind of like a fraction, a ratio, slope, rise over run, or in other words, we say y2 minus y1, the difference of the y's divided by the change in y divided by the change in x. So slope, it could be the slope of a tangent line, it could be the slope of a normal line. A tangent line would look something like this, and if this is F, then the tangent line would be like this here, so probably like that. The tangent of a, so this would be a tangent, this would be the normal, would be the normal, okay, so this is the tangent line, this would be the normal line. And of course, there's a different, this is perpendicular to the tangent line, right? So there's a rule for that, all right? So tangent lines, normal lines, is the slope, okay? Anytime you see the word rate of anything, you are dealing with a derivative. So a lot of times you'll see something in terms of velocity, maybe. So if you had something like meters per second, see if I can find something that writes. I haven't written on this board in a while. Miles per hour, or meters per second. In this case, this would be meters per second. Miles per hour would be more like this. Okay, and if you take let's just do meters per second, which is really equal to meters per second squared, that's acceleration. Okay, it's still a rate of a rate. You're still taking a rate. This is the kind of what we might say, the second derivative will give you acceleration. The first derivative will give you meters per second, miles per hour, feet per second. Okay. Also, if you want to look at volume, okay, if you see something about the volume of something is increasing or decreasing, the volume of a sphere, the volume of a cone. A lot of times you're going to see cubic centimeters per second, or maybe cubic meters per minute, something like that. But still, it is a ratio, it is a rate of change of the volume. Well, getting bigger, getting smaller. Okay, so that. And I wish I could flip my board over, but for the time being I cannot. Okay. Let's look at some more things that is, and then we'll look at a quick example. So we could look at increasing or decreasing functions. Alright? Increasing, decreasing at a rate. Something is increasing or decreasing. Or is the graph is the graph of G increasing or decreasing? Okay? Increasing, going upward, decreasing, coming down. Okay? The slope is what you're looking at there. Is a graph concave up or concave down? concave up, this would be up, this would be down. Here you would have a min. The slope is going to be 0. M is 0. Here you have a max. The slope is still 0. First derivative would be a min or a max. The second derivative is a concave up, concave down. Okay? If your answer is positive, it's concave up. If the answer is negative, it's concave down. So that would be a second derivative. First derivatives, increasing or decreasing. Maxes or mins. Second derivative, concave up, concave down. Okay. And sometimes you can actually go further into a third derivative or so on, you know, if you wanted to, with certain equations. Let me give an example of how to do a basic derivative. Alright, let's take a look. I'm just going to give you a problem, and I'm going to show you how to find the derivative. Now, there's so many things we could do, but for the lack of time, we don't have time to do them all. Have what you call this kind of thing. Oh, let me just show you this too before we do a problem. Here's a ladder right here, and the ladder is sliding down the wall. Obviously, it's sliding down the wall. Now, at this point, you see this height. When it's sliding down, this is a rate. We call this y, so in this case, this is dy over dt. And because this is shrinking and shrinking and shrinking and shrinking, the answer is going to be negative. Okay? So, for example, -3 feet per second. Okay? And see, this is x here. X value here. So here's x. Alright? But x is increasing, isn't it? So this answer, maybe this is 4. Alright? Without going into detail that these two are always going to be the same, not so fast. So anyway, alright, so that's that. Alright, now let's get into a problem. I kind of love the ladder problem. That's what you'll get into if you get into related rates. Okay? Actually, that would be dy over dt and dx over dt. Alright, now I want to do a problem. If f or g, so we're going to do f, is 3x to the 4th plus 5x cubed and minus x squared minus 6x plus 8. Now you may be asked to find what's the slope of this, of the tangent line to this curve. Okay, well, you can do that. The slope would have to be prime at x. Okay, what represents the slope. Okay, here's how you do it. You multiply the exponent times the coefficient. So 3 times 4 is 12. And then you drop off 1. 4 minus 1 is 3. 5 times 3 is 15. Drop off 1 is 2. Simple, isn't it? Alright, minus. This is a 1. Understood 1. So minus 1 times 2 is 2. Already put the minus sign there. Take 1 away. You're down to 1. You get just an x. Just put the number down, because once you subtract this, x to the 0, x to the 0 power is equal to 1. So negative 6 times 1 is just negative 6 to get down to just that, just write the number down. Derivative of a constant is 0. Okay? And I don't want to go into an explanation of that. Don't have time for that. So just right there. Now, maybe we're looking at the slope at x equals, I don't know, let's pick 1. Yeah, 1's easy. 1's easier and it's quicker. I could pick 2, but anyway, 12 times 1 cubed. Okay, let's make it -1. Got to put -1 in there. That's all you do. Once you find the slope, you plug the number in place there. 15 times -1 squared. I want to know what it looks like at x equals -1. I want to know what the slope looks like, or what is the slope? What is the slope? -1. Okay. -1 cubed. Negative times a negative times a negative is a negative. So -1 times 12 is -12. Negative times a negative is a positive, so plus 15. Negative times a negative is a positive, so plus 2. And then minus 6. Alright. So, it doesn't matter how you do it really. Put it from left to right if you want to. There's 3 plus 2 minus 6. 5 minus 6. Slope is negative. Did that right, didn't I? -12 plus 15 is 3. Alright, 3 plus 2 is 5. 5 minus 6 is -1. So the slope is negative. Means to the left. Okay. Alright, so this could represent a number of things. Okay. Alright, we could find one more thing that we could do is we could find f double prime, the second derivative. Alright, we might be looking at concavity, concave up, concave down, but we'll just find the second for the lack of time. Double prime. Oh, I should have left the f prime there. Well, it is. It's right here. Ah, whoo! Thought I'd erased it. Take the second derivative. Now, don't go back to here. Go here. At the first derivative. Take the derivative of the derivative. All right, again. 3 times 12, 36. X squared. Take 1 off, remember. 3 minus 1 is 2. 15 times 2 is 30. X to the 1. Yeah, okay. And then, of course, remember, this is going to be just -2. And remember, the derivative of constant is 0. And that's all you have right there. Now, if you wanted to check for concavity at a certain number, you could do that. You could still look at concavity, concave up, concave down, at x equals -1. And again, I don't have time to really do that, but you could do that. Okay. Just kind of give you an idea. Now, there are other rules that you need to be aware of. There is the chain rule, there's the product rule, the quotient rule, and so you need to know what those rules are as well. Okay, so if I'm asked to do another video on this, I may do another video anyway, because I'm KP the Math G. This is the idea behind the basic derivatives. Okay, slope of a tangent line, slope of a normal line, still a rate of change. Anytime you see the word rate, it's a derivative. Do a derivative. If you're asked, one more thing really quickly, if you're asked how much money, how much, or how much oil, or how much water is in a tank, now you're doing what we call a definite interval from time t0 to time t2. After 2 minutes, how much water do you have in the tank? Okay, so that is not a derivative. How much? Okay, if you take that how much and you see how fast is the water going through the pipe into the tub, now you're doing a derivative. That's the difference. Okay. All right. This is KP the Math G signing off. Everyone have a great day.